Good morning, everyone. Myself Sudharani. Today, I'm going to discuss about the sentiment analysis in information retrieval system. So, in the sentiment analysis, before going to start the sentiment analysis, let's start with the baseline algorithms. Already in my previous classes, in my previous lectures, already I discussed about the baseline algorithms. But now, as the part of sentiment analysis, I want to just remind few points again. Here, sentiment analysis is also known as opinion mining. Is a natural language processing approach that identifies and categorizes the emotional tone as positive, negative, or neutral, expressed in a piece of text. Sentiment analysis uses computational methods to analyze text data and determine the underlying sentiment or attitude of the author towards a specific topic, product, service, of idea. Before going to discuss the sentiment analysis, okay, wait a second. Okay, here let's discuss about the baseline algorithm first. Then we will have the much discussion about the sentiment analysis. A baseline algorithm provides a starting point for this task, enabling researchers and practitioners to evaluate the improvements brought by more advanced models. Although not optimized for accuracy, baseline algorithms are easy to implement and offer a quick understanding of the data structures and inherent challenges. A baseline algorithm in sentiment analysis is a simple method used to predict sentiment categories, example positive, negative, or neutral. Types of baseline algorithms. Here we are having the different types of baseline algorithms. First is a majority class baseline, random classifier, lexicon-based approach, Navi Bayes classifier, evaluation metrics. Majority class baseline. A majority class baseline is the simplest possible prediction method used in classification tasks, including sentiment analysis. It always predicts the most frequent class found in the training data sets, regardless of the input. So majority class baseline is the simplest possible prediction method used in classification tasks, include sentiment analysis. It predicts the most frequent class found in the training data sets. How does it works? First, count the number of samples in each sentiment class. Example, positive, negative, neutral. Identify the most frequent class, majority classes. Predict that class for all input. See. Let's take an example. Let's take an example and discuss the majority class baseline algorithm. Here we are having review. Take the example of websites, online stores, and review system, feedback system. The review segment, see here, if you take the reviews of any online shoppings, the reviews, by reading the machine, by reading simply it cannot understand whether it is a positive review or the negative review. Review is a review. If you give the good, it will take as a review. It will take bad. If you give the feedback review as a bad, again the system will take it as a review. Then how to generate the positive review and how to generate the negative review. It's simply by checking the review, the system can't understand whether it is a good or the bad feedback or the review. So for that, we are having some keywords which is mentioned the positive or the negative. Let us see by taking that example. Here the reviewer given the review as I love this product. Here in this sentence, we are having some keywords which is showing towards positivity. Here, such kind of keyword is love. So by seeing that keyword, the analysis can be done as a positive. The sentiment analysis can be categorized this comment as the positive because it is having the keyword like love. Same like next one, excellent quality and service. Here by seeing this sentence, again we are having some keywords like excellent. Excellent is a positive word, so that's why the sentiment analysis can be count this review as the positive. Very satisfied with my purchase, very satisfied with my purchase. Again, here we are having the key term like very, a key term like satisfied, not very. Key term or keyword like satisfied. Again, the satisfied is also positive term, so the analysis will be generated positive. And next, terrible experience, not happy. Here we can see the terms like terrible means it is a negative keyword, and not happy, not is also the negative keyword. So terrible experience, not happy, it will taken as a negative. Next, worst product ever. So again the keyword here we can take as the worst, and again the sentiment, again the analysis can be categorized as the negative. So this is the first step where we are identifying the keywords from the review and categorizing the sentiment analysis either to positive or the negative, but depends on the keywords of the reviews given. So after taking or after categorizing the analysis, then the first step to do is count classes. So here we are having only 2 types of classes. So this is comes under which one? Binary classification. This comes under binary classification because here the classes are only 2 types, positive and the negative. Now count the positive ones and negative ones. How many positives are there? 1, 2, 3. The positive classes are 3. Then how many negative classes are there? 2. So 2 negative classes are there. So the counter classes is positive is 3, negative is 2. This is the first step. And in the second step, identify majority classes. So after counting the classes among the binary classification, now identify what are the majority classes we are having. Obviously, out of 5, the positive classes are 3 and the negative are 2. So the majority classes is the positive. So majority classes equal to positive. Majority classes equal to positive. So that is a step 2. So in the step 3, predict majority classes for all inputs. Predict majority classes for all inputs. So if we are receiving the following new reviews to classify, this is predict majority classes for all inputs. This is awful, great job, not good at all, really loved it. The majority class baseline will label all of them as this is awful, that is positive, great job, again positive, not good at all, not good at all, really loved it, positive, positive. Even though this is awful is clearly negative, the model predicts positive because it only knows the majority classes. So the remaining classes, so the majority classes is positive. So the next reviews can also be considered as the positive because it only considered the majority classes. So this is about the majority class baseline algorithm. Next one, random classifier. After majority class baseline algorithm, next one is the random classifier. Random classifier is in the context, random classifier in the context of sentiment analysis refers to using a random forest algorithm and assembling learning method to classify text sentiments as positive, negative, or neutral, providing insights into public opinions or user sentiments. So random classifiers is the context of sentiment analysis refers to using a random forest algorithm. So it works like assembling method. So random forest is an assembling learning method that combines multiple decision trees to make predictions. Bagging, it uses a technique called bagging, bootstrap aggregating. where multiple subsets of the training data are used to training individual decision tree. Random subspace, each decision tree is trained on a random subsets of the features in the data sets. Prediction, finally, the prediction is determined by averaging the prediction of the individual decision trees. A random classifier is a baseline algorithm that randomly assigns sentiment labels, example positive, negative, neutral, to text inputs without learning from the data. It acts as coin toss or dice roll predictor either. Uniformly random, all classes have equal probability or probability weighted class probability matches the training set distribution. Lexicon, next method is lexicon-based approach. The lexicon-based approach is a widely used method in sentiment analysis that relies on a predefined list of words, a sentiment lexicon, to determine the sentiment orientation of a piece of text. This method does not require training data, making it suitable for scenarios with limited label data. Sentiment lexicon, a collection of words and their associated sentiment polarity. Words can be labeled as positive, negative, or neutral. Examples: Sentiwordnet, AFINN, NRC, Emotion Lexicon, and Bing Lewis Opinion Lexicon. Polarity score, each word is assigned with a polarity score. Example: +1 for positive, -1 for negative. The overall sentiment of the text is determined by summing the polarity scores of individual words. Text processing, tokenization, splitting text into individual words or tokens. Stop word removal, eliminating common non-informative words. Lemmatization, stemming, reducing words to their base or root forms. Types of lexicon-based approach. Dictionary-based approach uses manually or semi-automatically created lexicon. Example: using WordNet to expand synonyms and antonymy relationships. Advantage: high interruptibility. Limitation: cannot handle domain-specific language well. Corpus-based approach builds or expands a lexicon based on the statistical analysis of words, word co-occurrence in large corpora. Example: if amazing frequently appears with excellent, it may also be inferred as positive. Advantage: can adapt to new domains or slang. Limitation: requires large corpora and complex processing. Next algorithm is Navi-Bayes. Navi-Bayes is a probabilistic machine learning algorithm based on Bayes' theorem with a strong assumption of feature independence. In sentiment analysis, it used to classify text into sentiment categories like positive, negative, or neutral. Bayes' theorem, here we can see the Bayes' theorem of the formula PC by X equal to PC by C dot PC by Px. The terms can be derived as PC by X is posterior probability of class C given into X. Px by C, likelihood of input X given class C. P of C, prior probability of class C. P of X, evidence probability of input X. Evaluation metrics. Evaluation metrics are essential to measure the performance of sentimental analysis models. This metrics helps us understanding how well a model can classify sentiments like positive, negative, or neutral from the text data. So this is some introduction about baseline algorithms. This is some introduction about types of baseline algorithms like majority class baseline, random classifier, lexicon-based approach, Navi-Bayes classifiers, and evaluation metrics. Now let's start sentiment analysis. Now let's start discussing the sentiment analysis. Sentiment analysis is a branch of natural language processing that focuses on understanding and extracting opinions, emotions, and attributes and attitude expressed in text data. Its goal is to determine the sentiment of a piece of text, whether it's positive, negative, or neutral. So text and sentiment analysis branch of natural language processing that focus on understanding and extracting opinion, emotions, and attitude. Let's take one example. There is an English phrase or there is an English paragraph. See, if a person is standing in front of you and if a person is talking in one language, you can understand either the language he's spoken is in the positive way or negative way. For example, if a person standing and tell me, please leave me, please, if a person is standing and tell me, please, will you go from the class? So that word, if you are directly seeing the person, and if you are listening the voice of the person, and if you are seeing the facial expressions of the person, you can easily understand what is the emotion by seeing the emotion and by seeing the voice and by seeing the facial expression. You can understand either he is angrily telling, he is telling by sad, he is telling angrily, or he is telling requesting manner. Directly by saying that persons, we can understand. But when you are reading one text, then how you will understand what is the emotion of the text, what is the content of the text, means either it is this sad, or the author is narrating in a sad way, or the author is angry, or the author is happy. Which kind of emotion we will understand just by seeing the text. So that kind of capturing the emotions, positivity of the text or the negativity of the text is called as sentiment analysis. Just now we taken some example of a review, online store review. The system will consider the review as review only. It won't categorize the review as positive or negative until and unless we use the sentiment analysis algorithm. So by taking the sentiment analysis, we consider, by using the keywords, we consider which type of text it is, which type of review it is, either it is a positive review or the negative review. Text input. Sentiment analysis typically begins with a body of text as input. This could be anything from product review, social media post, customer feedback, news articles, or any other form of text data. So from there, or what kind of text input we can take for the sentiment analysis? Sentiment analysis typically begins with a body of text. It can be take the input from any of the corner, like product reviews or social media posts or customer feedbacks, news articles, or any other form of text data. So it can take any kind of input from any source. Next, pre-processing. Before analyzing the data, the text often undergoes pre-processing steps such as tokenization. In our previous class, in our yesterday's lecture, I explained about the tokenization and stop word removal, stemming or lemmatization. And on stemming and lemmatization, I taken a separate class also. So I think here again, clear explanation is not required. So pre-processing, on the text pre-processing also, I taken a separate lecture. Lemmatization and stemming also, I taken separate lecture. So again, the pre-processing, in the pre-processing, we are having the default steps for the pre-processing. The first one is lowercase, converting the text into lowercase. Next, removing the punctuation. Next, removing the stop words. Next, tokenization. Next, stemming and lemmatization. So these are the standard steps in the text pre-processing. So same here, it is mentioned tokenization means breaking down the text into individual words of the phrase. Here, people has to remember one thing: tokenization. If the input is in the just like the phrase or n number of sentences, then first sentence tokenize has to be done. Means the phrase has to be divided into different sentences. Then from the after the sentence tokenization, then that word tokenization has to be done. That from sentence we are dividing, the each word. stop word removal, as we said, there are some stop words in any sentence, like and, it, is, the, that. Such kind of things are called as the stop words, and we used to remove the stop words. Why? Because the stop word doesn't sense anything while framing the sentence for the to search the words in the search engine. So that's why by removing the stop words here, then the search can be done easily by identify the main keywords. So that's why stop words will be removed. Stemming and lemmatization, both are somewhat same, stemming and lemmatization with the slight changes. And in my previous class, I clearly explained what is the differences between the stemming and the lemmatization. If it is having the small differences also, overall common thing about the stemming and the lemmatization is both will be convert the word into its root word. It will consider the convert the stemming word into its root word. What is the necessary to convert the stemming word into the root word means, again, with the stem word, the search cannot be matched exactly, and the results will be less. So when you convert it to the root word, the searching will be optimized, and the searching will be possibility of the searching will be more, and we get the appropriate search things. Sentiment classification. The main task of sentiment analysis is to classify the sentiment of the text into predefined categories, usually positive, negative, or neutral. Some approaches use more granular scales, such as very positive, neutral, negative, and very negative. Every data analyzing process has a definitive procedure to determine the facts and maintain the accuracy of the model. Below we have defines how a basic sentiment analysis model works. So now let us see step-by-step procedure for sentiment analysis. First step is tokenization. Again, the tokenization involves dividing the given sentiment into different set of words, or dividing the given paragraph into a different set of statements. For instance, the given statement is, take the example, this flavor of chocolates taste bitter. So what is the text here? See, I will take the example and try to explain. So this flavor of chocolates taste bitter. This is a statement or the sentence. So here, this according to the tokenization, the sentence has to be divided into a single word. So now don't think that it is a stop word, it is a punctuation, leave about everything. Tokenization means only dividing the sentence into the words. So then this comes under what? This is separate word flavor, separate word of, separate word chocolate, separate taste, separate bitter, separate. So we're done with the organization, dividing the sentence into words. Second step, cleaning the data. So in the cleaning the data, here we see that once the step of tokenization is done, we perform the data cleaning. In this stage, we remove special characters in the data that add no values to analytics. As the above given statement doesn't have any special characters, we skip this. So what are the special characters? See here, this sentence doesn't have any special characters. But what do you mean by the special characters? Means punctuation marks. We can call it as the punctuation marks. Question mark, exclamatory mark, like asterisk, like special symbols. special characters. So such kind of things are called as the punctuation marks, like exclamatory mark. So all these things are called as the punctuation marks. So if any punctuation marks are there, we have to delete even the punctuation marks also. But here sentence doesn't have any punctuation marks, so no need. We can skip. Next, remove the stop words. Now, just now I explained what is a stop words. Stop words means some words unnecessary. We can't say completely they are the unnecessary words, but in the search engines to give the search word, if we give with the stop words, the sentence doesn't mean much to get the appropriate result. So if we remove the stop words, then the exact keyword can be generated and it will be helpful to generate the exact result for what we are searching. So that's why we have to remove the stop words. And the stop words are again like is, that, they, the, and, for such kind of words are called as the stop words. So during the third step, we remove all the words that don't add any value to phonetics. For instance, the word. So here, here in the sentence, what are the stop words we can consider? We can consider the stop words as this. These two are the stop words. So as a third step, remove the stop words, that and this, and generate the sentence. And fourth step, classification and calculation. During the classification process, we define the remaining words in the statement as either positive, negative, or neutral. Every positive word gets a score of +1, while a negative word is scored with a -1, and a neutral word is given 0 as a score. During this stage, we apply supervised machine learning algorithm to identify the given word as positive, negative, or neutral. During classification, you can train your machine learning model to identify defined words with sentiments, or you can add lexicon, a dictionary, or pre-classified words to perform sentiment analysis. From the above statement, the left out words are means after removing stop words, after removing punctuations marks, we got the words like only flavor, chocolates, taste, bitters. These are the words remain after doing the stop word removal and the cleaning, that is removing the punctuation marks. So now let us take these words and categorize them positive by giving +1 and negative by giving -1. First word is flavor. Flavor, we cannot say flavor is completely positive or flavor is completely negative. So here we choose flavor score as 0 because it can be considered as a neutral word. Chocolate again, chocolate, can't say chocolate as positive or negative. So we given for chocolate also 0 again as a neutral word. Taste may be bitter, taste may be bad, taste may be good, taste may be spicy, taste may be salty. Like that, taste cannot be again given as good or bad. So again, taste also got 0 and neutral. And last word is bitter. Bitter is clearly said it is a negative. So we are giving us -1 as a negative statement. So once we have done scoring, we calculate the final sentiment score. In this case, the score is what? Flavor is 0, plus chocolate is 0, plus taste is 0, and bitter is -1. So the result of score is -1. Since the polarity is lesser than 0, the given statement is negative. So the polarity should be more than 0, then only it will consider as positive. If the polarity is 0, then it is considered as neutral, and the polarity is less than 0, it considered as the negative. So I think people understand clearly how to calculate the polarity values in the sentiment analysis. Different levels of sentiment classification. different levels of sentiment classification. Once we find out the sentiment of a given statement, to define the polarity of a sentence, that is, whether the statement expresses sentiment classification. If yes, then whether it is a binary classification, means positive or negative, or multi-class classification, extremely negative or extremely neutral or neutral. This kind of analysis can be done at several levels of granularity. See, classification, as we discussed in the lecture of classification, clearly seen that classification is of two types, that is the binary classification and multi-class classification. In the binary classification, there is strictly only two classes are there. Either the two classes can be named as positive or negative, or true or false, or pass or fail, high or low, yes or no. Like that, we can name anything, but overall, the classes in the binary classification, the classes are only two. But at that, in all the situations, the binary classification cannot be sued. In some situations, we go with multiple options. That is called as multi-class classification. So after find outing the sentiment values, then we have to identify either we can use the binary classification, like only positive, negative values are there, or multi-class classifications. Here in the previous example, we see that we are having negative, but in some situations we may if see. Here, if this is also 0, this -1 bitter value is also neutral 0, then the output will be 0, right? So if that value output is 0, the granularity value is 0, then what kind of feedback or the review we can give that is neutral? So if we take the neutral, then how can it set with the binary classification? Why? Because in the binary classification, only two types are there, either positive or negative. But with the previous example, we can get we are having a chance to get as a neutral. Then binary classification won't work. Then there we go with the multi-class classifications, where like extremely negative or extremely neutral or neutral. See, sentiment analysis, word level sentiment analysis, sentence level sentiment analysis, document level sentiment analysis, feature-based sentiment analysis. These are the categories in the sentiment analysis. Let us see word level. Word level sentiment analysis is the breakdown of a sentence and document into words that are strongly adjectives to define the polarity of words for further defining the sentiment of the sentence. So word level sentiment analysis is breakdown of the sentence and document into words, just we done in tokenization. That strongly adjective to define the polarity of words for further defining. So here the difference between the tokenization and the word level sentiment analysis is, in the word level, we are dividing and strongly defining the polarity values to the every word. Sentence level or phrase level analysis dealing with tagging individual sentence into their respective sentiment polarities through determining the sentiment of each word and combining them to determine the sentiment of the whole phrase. So here in the sentence level, what we are doing means, first the sentence level is dividing into the different phrases of the sentence, different phrases or the text, and every phrase is giving a tag, and then overall phrase can be determined with the tags. Next, document level. It deals with tagging individual documents either into positive or negative sentiment. The sentiment classification works similarly. First, we identify the sentiment of each word, and then combining them to identify the sentiment of each sentence, and combine all sentences scores to identify paragraphs, and so on to define the sentiment of document. So in the document level, it deals with tagging individual document either into positive or negative statements, and then sentiment classifications work similarly. Feature level. Aspect level or feature level sentiment classification deals with labeling each word with their sentiment and also determining the entire entity towards which sentiments is directed. Techniques used in sentiment analysis. Lexicon based. These methods use lexicons or dictionaries containing words associated with sentiment polarity, positive, negative, or neutral. The sentiment of a text is determined based on the presence of frequency of these words. Machine learning, first one is a lexicon based. In the lexicon based sentiment analysis, containing words associated with sentiment polarities, means positive, negative, and the sentiment of a text is determined based on the presence and frequencies of those words. Machine learning techniques involves training a model on labeled data, text samples with known sentiments to predict sentiment in new unseen text. Common machine learning algorithms for sentiment analysis include Navi bias, support vector machines, and recurrent neural networks, RNNs. So these are some of the machine learning techniques. Next, deep learning. Deep learning models, particularly variants of neural networks, like convolutional neural networks and long short-term memory networks, have shown great effectiveness in sentiment analysis tasks due to their ability to capture complex patterns in the text data. We've seen what are the different types of sentiment analysis we are having, and up to now we've seen what are the different types of sentiment analysis, what are the different techniques used in the sentiment analysis, and now what are the applications of techniques used in sentiment analysis. First, let us see the evaluation pattern. Sentiment analysis models are evaluated based on their accuracy in correctly classifying the sentiment of text samples. Common evaluation metrics include accuracy, precision, recall, and F1 score. These four are the evaluation patterns for sentiment analysis: accuracy, precision, recall, F1 score. Business. Understanding customer sentiment towards products or services, analyzing social media for brand reputation management, and guiding marketing strategies. Finance is also one of the applications of sentiment analysis, analyzing sentiment in financial news and social media for stock market prediction and trading strategies. Politics, analyzing public opinion on political issues and sentiments towards politicians. Customer service, automatically categorizing and prioritizing customer feedback for better response management. Healthcare, analyzing patient feedback to improve healthcare service and patient satisfaction. These are some of the applications of sentiment analysis. Document level sentiment analysis. The document level sentiment analysis module analyzes a piece of text and determines whether the text has a positive or negative sentiment. It supports any sentiment bearing text. That is, text which are not too short. Numeric includes only the street address or an IP address. It aims to classify an opinion document as expressing a positive or a negative opinion, which are called sentiment orientations or polarities. The task is referred to as document level analysis because it considers each document as a whole and does not study entities or aspects inside the documents or determine sentiments expressed about them. Document sentiment classification is considered the simplest sentiment analysis task because it treats sentiments classifications as a traditional text classification problem with sentiment orientations or polarities as a class. Any supervised learning algorithms can be applied directly to solve the problem. Methods and techniques. Lexicon-based approaches. These methods utilize sentiment lexicon or dictionaries containing words annotated with sentiment polarities. The sentiment of the document is determined based on the aggregation of sentiment scores of the individual words, considering their frequency and intensity. Sentiment lexicons or curated list of words, phrases, each assigned a sentiment plurality labels. These lexicons are typically manually created or compiled from existing resources and may vary in the size and coverage. Example lexicon. Some well-known sentiment lexicon includes the SentiWordNet, AFINN, Effective Norms for English Word, VADER, Valiance, Away Dictionary, and Entainment Reasoner, and MPQA, Multi-Perspective Question Answering Lexicon. These are some of the names of the lexicons. One more method we can use, that is machine learning. Supervised learning methods such as support vector machines, NaviBias, or random forest are trained on labeled data sets to classify the overall sentiment of the document. These models learn patterns from labeled examples and then apply this knowledge to classify unseen document. Deep learning method. Deep learning models, including convolutional neural network CNNs and recurrent neural network RNNs, have shown promising results in document-level sentiment analysis. This model can capture complex relationships and patterns in text data, allowing for more accurate sentiment classification. Lexicon-based approach. Sentence level sentiment analysis plays a crucial role in understanding the sentiment expressed within the individual statements, providing insight into opinions, attributes, and emotions expressed within the text data. Sentiment lexicon. We will use a sentiment lexicon containing words annotated with sentiments polarity labels, either positive, negative, or neutral. Sentiment scoring. Each word in the sentence is assigned a sentiment score based on its polarity label in the lexicon. For example, amazing, it can be scoring can be as positive. Disappointing, it can be score as negative. Next, aggregation. The sentiment scores of individual words are aggregated and determine the overall sentiment of the sentence. In this case, the presence of both positive and negative words indicates a mixed sentiment. Classification. Depending on the aggregation method and threshold, the sentence may be classified as neutral or may be assigned a label indicating a mixed sentiment. Example analysis. We can take sentence as, the movie was amazing, but the ending was disappointing. The movie was amazing, but the ending was disappointing. Let us check the sentiment score. Amazing, we can identify the keywords and we can give the values. Amazing, that is +1 for positive, but neutral. Ending, -1 as negative. Disappointing, -1 as negative. Now let us calculate the aggregate score, that is +1, -1, -1, that is equal to -1. That is mixed sentiment. So this is called mixed sentiment. Lexicon-based approach, document-level sentiment analysis. Here in the document level sentiment analysis involves accessing the sentiment expressed across an entire document, such as review articles or social media posts. Here's a simple example illustrating how document level sentiment analysis might work. See, lexicon-based approach, sentiment lexicon. We use a sentiment lexicon containing words annotated with sentiment polarity labels and calculate the sentiment scoring. Take the example of pleasantly surprised. So it is a positive. Pleasantly is a positive. We can give +1. Delicious, it is +1 and positive. Exceptional, +1 and positive. Lacking, -1 negative. Higher, -1 negative. Good, +1 positive. Room for improvement. Room for improvement is -1 negative. So like this, we can calculate the aggregated score. Next, aggregation. The sentiment scores scores of individual words are aggregated to determine the overall sentiment of the document. In this case, the positive sentiments outweigh the negative ones. Classification. Depending on the aggregation method and threshold, the document may be classified as positive, negative, or neutral. Example analysis. Take the document as I recently visited this restaurant and I must say I was pleasantly surprised. The food was delicious and the service was exceptional. However, the ambience was a bit lacking and the prices were on the higher side. Overall, it was a good experience, but there's room for improvement. So for this, we've seen this slide. So for this sentiment scores, here we can, by seeing this, we are getting 4 as 1, 2, 3, 4. +1 are positive side are 4. They are pleasantly surprised, delicious, exceptional, and good. And the remaining 2 are negative, lacking, higher, room for improvement. So aggregated score is +4 positive, -2 negative. So that is overall +2 is positive. And the last one is aspect-based sentiment analysis. In aspect-based sentiment analysis, the first step is to identify the specific aspects or features mentioned in the document. These aspects can vary depending on the context, but often include attributes such as design performance, battery life, camera quality, etc. In the example document, design sleek and modern, battery life leaves much to be desired, camera quality impressive, performance occasionally lack. Sentiment analysis for each aspect. For each identified aspect, sentiment analysis is performed to determine the sentiment expressed towards the aspects. This can be done using lexicon-based method, machine learning method, or a combination of both. Design, see, in the design we take sentence as sleek and modern. Design this positive sentiment like sleek and modern. Camera quality, it is positive as it is impressive. Battery life, negative statement, leaves much to be desired. Performance, negative statement, occasionally lag. So these are some of the explanation regarding the types of sentiment analysis, applications of sentiment analysis. So overall, we've seen steps in the sentiment analysis. The first step is tokenization. We're converting the sentence into the words. Next, cleaning the data means removing the punctuation marks, punctuation symbols. Next, removing the stop words like that, this, there, off, like that. That is the step 3. Remove the stop words. Step 4, classification and calculations. We've seen how to calculate the positive words and negative words and how to calculate the polarity score. If the polarity score is below the 0, then it can be considered as negative. Polarity score above 0, positive, and polarity score is 0, it can be considered as a neutral. Different levels of sentiments. We've seen all the different levels of sentiments like word level, sentence level, document level, and the feature level. So word level, sentence level, document line level, and the feature level. Techniques used is sentiment analysis. We are having the techniques like lexicon-based, machine learning-based, deep learning-based. These are some of the techniques. Applications of sentiment analysis. We are having a lot of applications: business, finance, politics, customer service, healthcare, and a document level sentiment analysis. In the document level sentiment analysis, piece of text and determines whether the text has a positive or negative. It supports any sentiment bearing text. The task is referred to as document level analysis because it is considered each document as a whole. And in the document level sentiment analysis, methods and techniques we used are lexicon based methods. And examples of lexicon based methods are again machine learning, deep learning. And in the machine learning, again for the lexicon, we go with SVM, support vector machines, NaviBias, or random forest. And deep learning, we go with conventional neural networks, CNN, and the recurrent neural networks, RNN. This is about document level. Next, lexicon-based approach, sentence level. So for the sentence level analysis, here we are having the sentiment lexicon, sentiment scoring, aggregation, classification. Sentiment lexicon containing words annotated with sentiment polarities, labels, positive or negative. Sentiment scoring, each word in the sentence is assigned a sentiment score based on its polarity label in the lexicon. And aggregation, the sentiment scores of individual words are aggregated to determine the overall sentiment of the sentence. Classification, depending on the aggregation method and threshold, the sentence may be classified. Here is example. Example for document level sentiment analysis. Aspect-based sentiment analysis. Aspect-based sentiment analysis means we are dealing with the different types of phrases or the text way to analyze. So this is few points about the sentiment analysis. Now see what are the applications and tools of sentiment analysis. Applications of sentiment analysis, social media monitoring, analyze opinions of platforms like Twitter, Facebook, and Instagram. Examples, tracking public sentiment during elections or brand campaignings. Customer feedback analysis, evaluate reviews on products, services, or apps. Amazon or Google Play Store reviews to improve product features. Market research, brand monitoring. Understand customer behavior and brand perception. Example, tracking competitor sentiment trends across the web. Financial market prediction. Extract sentiments from financial news and tweets to predict market movement. Example, stock price prediction based on economic sentiment. Customer support, detect negative emotions to support tickets or live chats to prioritize responses. Example, automating escalation of highly dissatisfied customer queries. Healthcare and patients feedback. Analyze sentiment in patients reviews or mental health forums. Example, monitoring emotional well-being through therapy apps inputs. Tools and libraries for sentiment analysis. Tools, NLTK, this is the most used toolkit, NLTK. Description, rule-based sentiment analysis, suits for social media text. Next, TextBall, simple Python libraries for sentiment and polarity classification. Spicy plus text classifier, industrial strength NLP with custom classification pipeline. Transformers, Hugging Face, retained models like BERT for deep contextual sentiment analysis. stand for Core NLP, Java-based NLP toolkit with a built-in sentiment annotator. AWS comprehensed Google Cloud NLP, Azure Text Analytic, cloud-based apps for sentiment analysis. These are some of the tools where we used for the sentiment analysis. Aspect terms, aspect-based sentiment analysis. Aspect terms, the Lasanga was great, but we had to wait 20 minutes just to be seated. Aspect term, Lasanga, positive sentiment. Aspect categories, the Lasanga was great, but we have to wait 20 minutes just to be seated. Aspect categories, food, positive sentiment, service, negative sentiment. Aspect-based sentiment analysis. Given a customer review, automatic systems are to determine aspect terms, aspect categories, and sentiments towards these aspects, terms, and categories. Training data, two domain-specific data sets for laptops and restaurants consisting of over 6K sentences with fine-grained aspect-level human annotation. Subtask, aspect term extraction, aspect term polarity, aspect category detection. Customer reviews provided for two domains, restaurants and laptops. 5 aspect categories are defined for the restaurant domain: food, service, price, ambience, and anecdotes. No aspect category for laptop reviews. Aspect category polarity. Automatic systems are to determine if any one of those aspect categories are described in a review. Resources in domain Corpora, 1,80,000 Yelp restaurants review, Phoenix academic datasets, 1,25,000 Amazon laptop review, sentiment lexical terms and degrees of their associations with positive or negative sentence. What aspect association lexicon, terms and degrees of their association with the aspect categories. Corpora, the Yelp Phoenix academics datasets contains customer reviews posted on the Yelp website. The business for which the reviews are posted are classified into over 500 categories. Amazon laptop reviews corpus, collector reviews posted on Amazon.com. A subset of 1,24,712 reviews that mention their laptop or notebook. 5-star rating, 1 to 2 negative, 4 to 5 positive. What aspects corporate generation? What aspect corporate generation? Star rating in reviews. Star rating in reviews are used as weak labels. Score W, PMW positive minus PWMW negative. If score is greater than 0, then what W is positive. If score is less than 0, the what W is negative. Affirmative and negative context are treated separately. So here we can see the desserts are very overpriced and not very, the desserts are very overpriced and not very tasty. Here the sentiment of review The yellow color can be shown as a sentiment of review. The dark color can be shown as negative context. Affirmative context of corpus, sentiment of reviews, and the negative content corpus. Here we can see frequency of word comma POS. POS stands for spots of speech. In the number of times a term W occurs in positive review. Frequency of W is the total frequency of term W in the corpus. Frequency of POS is the total number of tokens in positive reviews. N is the total number of tokens in the corpus. PMI, W comma negative calculated in a similar way. Ignore terms that occur less than 5 times in each positive negative group of reviews. Negated context defined as text spans between a negation words and a punctuation marks, and affirmative non-negated context. Sentiment scores were then calculated separately for 2 types of context. The term good in affirmative context has a sentiment scores of 1.2, whereas the same term in negated context has score of -1.4. Out-domain sentiment lexica. Large coverage automatic tweet sentiment lexicon, hashtag sentiment lexicon, sentiment 140 lexicons, 3 manually created sentiment lexicon, NRC emotion lexicon, Bing Leo lexicon, MPQA subjective lexicon, Yelp restaurant word aspect association lexicon. Each sentence of the corpus was labeled with 0, 1, or more of the 5 aspect categories by our aspect category classification system. For each term W and each category C, an association score was calculated, where score of W comma C equal to PMI W comma C minus PMI of W comma C. Subtask 1, aspect term extraction. Task to detect aspect term in a sentence. So approach semi-Markov discriminant tagger trained with MIRA perception. Tags phrases, not tokens, can use phrase level features. Features, emission features, token identity, case lowered. So result, restaurants, laptops, restaurants PR F1. Precision recall F1 score, that restaurants we got 84.41. Russian we got 78.37. F1 score we got 80.19. For the laptop, same scores we got 78.77, 60.70, 6.57. Tagger features. Token features templates for WI, token identity within a window, lowercase token identity within a window, prefixes and suffixes of WI up to 3 characters in length. Phrase level emission features templates. The cased and uncased identity of the entire phrase covered by a tag, which allows the systems to memorize complete terms such as getting a table or fish and chips. Transition features templates or short and grams of tag identities. Next up, 2, this is one more example. To detect sentiment towards a given aspect term, SVM with linear kernel, features, surface features, n-grams, context target, bigram, sentiment lexicon features, count, sum, max, syntactic features, n-grams and context targets, bigrams on phrase trees, phrase label features. And here we got results, domain accuracy for the restaurants, the accuracy is 0.16, laptops we got 49. Features, surface features, unigram single word, bigrams 2-word frequency extracted from a term and its surface context, context target diagrams, lexicon features, the number of positive negative tokens, the sum of the token sentiment scores, the maximal sentiment scores. Parts features, word and POS. Again, POS stands for parts of speech engram. Context target bigrams, that is bigrams composed of a word from the phrase context and a word from the term. All paths that start or end with the root of the target terms. Task 3. So we are having subtask 3. In the subtask 3, detects aspect category discussed in the sentence. Approach SVM. Here we are using the approach, different approach. SVM with linear kernel. 5 binary classifiers. 1 versus all. Features word and character engrams, stemmed engrams, porter stemmer, word clusters engrams. The result is domain restaurants 91.04, 86.24, 88.58. So in the task, in the subtask 4, we are using sentiment lexicon features. So the accuracy got is 82.93. NCR Canada results. Top results on subtask 2, 3, and 4. Statistical approaches with surface form and lexicon features. Most useful features derived from automatically generated in domain lexical features. Task, subtask A, given a tweet, decide whether it expresses positive, negative, or neutral sentiments. Subtask B, given a tweet and a topic, classify the sentiment conveyed toward the topic on a 2-point scale. Positive versus negative. Subtask C, given a tweet and a topic, classify the sentiment conveyed in the tweet towards the topic on a 5-point scale. Strongly positive, weakly positive, neutral, weakly negative, and strongly negative. Subtask D, given a set of tweets about a topic, estimates the distribution of tweets across the positive and negative classes. Subtask E, given a set of tweets about a topic, estimate the distribution of tweets across the 5 classes: strongly positive, strongly weakly positive, neutral, weakly negative, and strongly negative. Text processing, unlabeled data set, collecting a big data sets of 330 English Twitter message, which is used for calculating what statistics need by our text processor. Training word embedding, tokenization, recognizing the Twitter markup and some basic sentiment expressions, emotions, expressions such as dates, like example 7/11/2011, April 23rd, timings like 4:30 p.m., 1 a.m., currencies like dollars, acronyms, censored words, words with emphasis, and more. Text post processing, perform spell corrections, word normalization, and segmentation, and decides which tokens to omit, normalized, or annotate, surround, or replaced with special tags. Architecture of task A, bidirectional LSTM, bidirectional and clause probabilities. This is the MSA model, a two-layer bidirectional LSTM with attention over the class layer. Next, this is for task A. This is for task C. So mean polling, shade weights, max out, soft max. So TSA model, a seamless bidirectional LSTM with context aware attention. Conclusion, paradigm shifts in 2015 to 2016 from traditional SOTA classifiers with features of SVM, macro models, and deep recurrent or convolutional neural network using word embedding as features. And just check again from. So here we see in the aspect terms, how to calculate the aspect terms and how to calculate the aspect categories. And what are the subtasks? First, aspect term extraction. Second, accept term polarity. Third, aspect category detection and aspect category polarity. Next, resources from which corpora we are getting the data sets like in domain corpora, Yelp restaurants reviews, Amazing laptop review, sentiment lexicon, word aspects association lexicon, corpora, word aspects corpora generations, point-wise mutual information, negated context, out-domain. And here we are using subtask 1 where we are using the tag engram. Tagger features, token features template, phrase level emission feature. And in the subtask 2, we use a sentiment lexicon features, engrams, context target bigram, sentiment lexicon, engrams and context target bigram. Features, surface features, we use like engram, unigram, bigram, and context target bigram. Lexicon features, parse features. And in subtask 3, again, we use SVM with linear kernel, 5 binary classifier. And here we got for the restaurant, we got pressure 94.04, recall 86.24, F score, F1 score 88.58. And in subtask 4, again, we use sentiment lexicon feature, we use word and character engram, POS tagging, sentiment lexicon feature. So this is few things. And next we are having lexicons, corpora, and comparative sentiment analysis. Sentiment lexicon is a collection of lexicon entries, usually words or multi-words expressions, annotated with sentiment polarities and sometimes intensity scores. Types of lexicon, general purpose lexicon. These are widely applicable and cover a broad vocabulary. Examples include senti-ordinate, assign sentiment scores to ordinates and synset. AFINN contains English words with sentiment scores ranging from -5 to +5. NRC emotion lexicon, tag words with emotions, example, anger, joy, polarity, positive, negative. Domain-specific lexicon, created for specific fields such as finance, medicines, or product review. They tend to be more accurate within their domain, but like generality. Structures of lexicon. Structures of lexicon. Each entry in a sentiment lexicon typically consists of word or phrase, the token being analyzed. Polarity, the sentiment category, positive, negative, neutral, intensity, a numerical score representing the strength of the sentiment. Applications of lexicon, customer feedback analysis, understanding user opinions from reviews or surveys responses, social media monitoring, gauging public sentiment about events or brands, market research, identifying trends and customer preferences, political sentiment analysis, measuring voter sentiment from online disclosure. Example use case, consider the sentence. Now let's take a example and consider. The movie was surprisingly good, though the plot was predictable. Using a lexicon, good is positive, predictable is negative. Sentiment analysis might yield a mixed and slightly positive result. A more advanced lexicon-aware system might consider modifier like surprisingly to adjust the sentiment intensity. In sentiment analysis, a corpus refers to a large and structured set of textual data used for training, validating, and evaluating sentiment classification models. A well-designed corpus is crucial for the success of both lexicon-based and machine learning-based sentiment analysis system. It specifies type structures, applications, and significance of corpora in sentiment analysis, highlighting their role in enabling accurate and domain-specific opinion mining. A corpus in the context of sentiment analysis is a collection of text such as reviews, tweets, comments, or articles that are typically pre-prosed and annotated with sentiment information. A corpus in the context of sentiment analysis is a collection of text such as reviews, tweets, comments, or articles that are typically pre-prosed and annotated with sentiment information. Types of corpus, labeled annotated corpus. Each text unit is tagged with sentiment categories like positive, negative, or neutral. This is essential for supervised learning. Example, IMDb movie reviews, sentiments 140, Amazon product reviews, unlabeled corpus, raw textual data without sentiment annotations, useful in unsupervised or semi-supervised settings. Examples, Wikipedia articles, forums, posts, news archives. Domain-specific corpus collected from a specific industry or topics such as finance, health, or education. Domain relevance often improves model performance. Structure of a corpus. Typically, a corpus includes text data, sentences, paragraphs, or documents, metadata, information like dates or source, author, and language, annotations, labels for sentiment, subjective or emotions. Challenges in corpus construction, annotation quality, domain adaptability, language diversity, data privacy. These are few challenges in corpus constructions. Annotation quality, inconsistency in labeling due to subjective interpretation. Domain adaptability, a corpus built for one domain may not perform well in another. Language diversity, limited availability of high quality corpora in languages other than English. Data privacy, issues when dealing with sensitive or personal information in the text. Annotation quality, inconsistency in labeling due to subjective interpretation. Domain adaptability, a corpus built for one domain may not perform well in another. Already finished. Feature of comparative sentiment analysis. Comparative sentiment analysis involves multiple components. Entities, the item being compared, example, iPhone versus Samsung. Comparative words, terms such as better, more efficient, worse, then indicate comparison. Aspect features, attribute on which entities are compared, example, battery life, camera. Orientation, the direction of the comparison, which entity is preferred. Example statement, iPhone has a better camera than Samsung. Entities, iPhone, Samsung, aspect camera, comparative word, better. Orientation, iPhone is greater than Samsung, positive for iPhone. Comparative sentiment analysis. Comparative sentiment analysis is a subfield of sentiment analysis that focus on detecting and interpreting comparisons in textual data. It aims to identify sentiments expressed in comparative forms, such as product A is better than product B, to determine which entity is favored and why. This technique is essential for applications like product benchmarking, brand monitoring, and market research. This technique exploits the methods, challenges, and applications of comparative sentiment analysis and its relevance in natural language processing. We can take example. iPhone has a better, this is complete. So we've seen, in this session, we've seen what is lexicons and corpora. Said what is a sentiment? Sentiment lexicon is a collection of lexical entries, usually words or multiple words, and types of lexicon: general purpose lexicon, CentiWordNet, AFINN, NRC emotions lexicon, domain specific lexicon, and structure of lexicon. Each entry in a sentiment structure of lexicon, word or phrase, polarity, intensity, applications of lexicon, customer feedback analysis, and social media monitoring, market research, political sentiment analysis. Here we taken one example. And next one is a corpus. In sentiment analysis, a corpus refers to large and structured set of textual data, and a well-designed corpus is crucial for success of both lexicon-based and machine learning-based sentiment analysis system. It specifies types, structures, applications, and significance of corpora in sentiment analysis. And types of corpus: labeled or the annotated. Unlabeled labeled examples is IMDb. Unlabeled corpus, raw textual data without sentiment annotation. Examples: Wikipedia articles, forums, posts, news archives. Domain specific corpus. Structure of corpus: it is having text data, metadata, and annotation. Challenges in corpus constructions: annotation quality, domain adaptability, language diversity, data privacy. And if we take data privacy, deals with lot of problems in any application. So here also for the corpus also data privacy It has issues when dealing with sensitive or personal information in the text. Features of comparative sentiment analysis, entities, comparative words, aspect features, orientations, example statements, that is entities, aspects, comparative, orientation, and comparative sentiment analysis. Comparative sentiment analysis is a subfield of sentiment analysis that focus on detecting and interpreting comparisons in textual data. It aims to identify sentiments expressed in corporative forms, such as this technique is essential for applications like product benchmarking and brand monitoring and market research. This technique explores the methods, challenges, and applications. Example statement, and here in this example statement we can clearly see, we can see here the iPhone has a better camera than for Samsung. Here for the entities we can take two entities as iPhone and the Samsung, and the aspect is camera, on which aspect we are comparing the product A and product B, and the aspect is camera. The quality, we are comparing the quality of camera between two phones, that is iPhone and the Samsung. So aspect is camera. Next comparative word is better. Which camera is better? Orientation is iPhone greater than Samsung. So positive for iPhone. So we get the orientation positive for iPhone. So anything missing? So here today's in this 1 hour lecture, I clearly explained what are the baseline algorithms, what is the sentiment analysis, what are the toolkits for sentiment analysis, what are the applications of sentiment analysis, what are the types of sentiment analysis. So I hope you people all understand my lecture, and in the next class we will come up with the next one.